European passenger vehicles are typically a lot smaller than those in the US because fuel economy. So for fuel economy reasons, they have been using diesels as passenger vehicles for decades. A diesel engine, can get 50 miles per gallon, whereas a spark ignition is lucky to get 35 miles per gallon. So, or 40 maybe now. So that's why they use them in Europe.
I'm Miriam Hoffman, a full-time college student living in Carbondale, Illinois, and you're listening to the Vance Crowe Podcast.
Welcome back to the podcast. I'm glad you're here. Today, I interview a chemical engineer named Dave Slade. Dave is one of those green hippies that got into the energy world because he genuinely wanted to fight climate change. This is an interesting perspective for me, and it's not that I don't think climate change is real. It's just not something I spend very much time thinking about. But Dave is a chemical engineer in the energy world, which is a fascinating field that most people don't think or know anything at all about. And so we sat down and we actually had a really robust conversation about energy, comparing how biofuels compare with diesel fuel or solar or wind. This is a wide-ranging conversation where we actually get to hear the thoughts of a person that has spent about 15 years working as hard as they can to add energy into the system that will have no impact on the environment or future generations. So this is an interesting guy, and we're going to get to that interview in just a moment. But before we do, I wanted to talk about virtual reality. And I have two things I wanted to bring up with you. First, if you have a virtual reality headset and you don't know what to do with it, then you should know that every day in the last couple of weeks, I've been doing a coffee shop where I get into a coffee shop on VR, and anybody that has a headset is welcome to join me. And I've had a few people, and it's been pretty fun. So if that's something you're interested in, you have a headset and you don't know what to do with it, why don't you send me a DM on Twitter at Vance Crowe, and we can line it up. I can let you know what the app is that we use, and we can get connected. The other thing is that if your business has been thinking about VR, maybe you've been approached because one of the VR conferences that's just kicking off wants some sponsors, or they want you to participate, then you may be asking yourself, what is the state of the technology? How much of an investment should I make? What does it cost to develop in this space? And so my business partner and I, Ben Anderson, have created a virtual reality workshop where for as many people as you would like, we will give a presentation on the state of play as far as virtual reality, what we think is going on and where it's headed and over what time period. But then after that, you and 7 people that you get headsets for yourselves can then go on a field day with us where we'll guide you through various experiences on virtual reality to accelerate the speed with which you can get comfortable with the medium and then start to begin to understand how this is going to be impacting your industry and business. So if this is something you're interested in, I would love it if you would reach out to me, and you can always learn more by going to articulate.ventures, which is our website. And if you're one of those people that is doing the cold shower every day this month, how's it going? We have really had fun with this one. Inside of the Articulate Ventures Network, people are talking about it. They're talking about the visions that they've seen. They're talking about how much harder it was at first to do, and then how it's gotten better and what it's changed for them. So if you're one of those people that is interested and engaged and you're doing this cold shower, consider joining the Articulate Ventures Network, which will allow you to have a community of people that will talk about these various monthly experiences and help you work on becoming the best communicator that you can by exposing you to people from all different walks of life and ways of viewing the world. So if you want to learn more about the network, go to network.articulate.ventures. And now, without further ado, we're going to head to my interview with Dave Slade. Dave Slade, welcome to the podcast.
Thank you, Vance. It's great to be here.
So you're an interesting character that I just met, and yours is the first interview I've done where somebody reached out to me and said, you should interview this guest, because normally I'm thinking, hey, I've got questions I want to get answered, but I didn't even consider that there would be somebody out there with your expertise that we could sit down and talk about, which is energy, the thing that is all around us, everybody needs and uses every single day, but it is so ubiquitous that people don't even realize it's there. So what's your background? How do you know so much about energy, Dave?
Well, I'll give you a little bit of my personal story because it kind of explains how I got where I am. I was a chemical engineering student back in the 1980s and went to graduate school in 1991, partly because I didn't know what to do with myself. I'm from Kansas. I realized all my peers were getting jobs in the petroleum and petrochemical industries because that's where the chemical engineering jobs were, and I just wasn't ideologically able to do that. I'm not even sure what I thought I was going to do when I started being a chemical engineer in 1986, but I knew I was interested in environmental things and renewable things. So I went to graduate school, didn't find that opportunity in 1993, came back to my hometown in Lawrence, Kansas, and kind of bounced around for about a decade, worked in various jobs, some technical, some not, and I ended up teaching middle school and high school science and math at a private high school in my hometown. And while I was teaching science in particular to these students, I started to finally get very intrigued with all those concepts that I hadn't really grabbed onto my first time around. And I realized that all along I'd really been interested in energy, which is, what we're going to talk about today. And for some reason, I was just a little bit slow. It took me about 15 years to realize that chemical engineers were involved in all sorts of renewable energy opportunities, from nuclear to solar to biofuels now, which is what I do for a living. And so I decided to go back to school. At that point, I knew I loved teaching because I'd been teaching for a couple of years, and the only degree available to me in chemical engineering was a PhD. So I went back to get my PhD in chemical engineering, tried to find a project or an advisor that would be renewable, try to find opportunities to start in on that field. And what I ended up doing was getting exposed to hydrogen production, which was a really interesting background and very useful for, of course, the modern energy infrastructure. People talk a lot about hydrogen as a thing that started under George W. Bush.
I don't even know what you're talking about. What in the world? The hydrogen construct, like what?
Hydrogen energy. So hydrogen fuel cells. So, this is something that got promoted a lot back in the late 90s. And the idea still is that hydrogen, when it burns or combusts or reacts to form energy, it makes water. Because anytime you burn a fuel, think of it as you're reacting that fuel with oxygen, and you're making either carbon dioxide if the fuel is carbon based, or you're making water if the fuel is hydrogen based. And hydrocarbon fuels, liquid fuels, have both carbon and hydrogen. So when we burn liquid fuels, we make CO2 and water. So the idea of the hydrogen economy was, hey, we don't want CO2 because it's a greenhouse gas. CO2 contributes to global warming or climate change. So let's just do the hydrogen part, and we'll make water as our only product. So the only thing coming out your tailpipe, if it's a vehicle, would be water. And so hydrogen got a big boost in interest in the late 90s. So mid to late 90s. In particular, as I say, George W. Bush really was pushing the hydrogen economy, meaning let's replace all these, fossil fuels with hydrogen. So my PhD project was on making hydrogen. There also was a guy at University of Kansas where I was, who's a really prominent electrochemistry researcher, which means batteries basically. So along the way, I was able to take a course from him and learn things about batteries, which apply now for electric vehicles or electric energy storage. It's all about the batteries, which also are chemical reactions, by the way. We may get to that later. So just keep that in mind. Whenever anyone talks about a battery and an electric vehicle, there's still chemical reactions occurring inside that battery, and that's what gives them some of their limitations. So I learned a little bit about batteries. I learned quite a bit about making hydrogen. I also learned about biodiesel, which at the time was the only renewable or sustainable diesel fuel option. There's some more now. And so I realized that hydrogen had its limitations. I wasn't too excited about that as a widespread solution. It's a very niche thing. Batteries made a lot of sense, but you still have to have electricity. The electricity has to come from somewhere. At the time, it was mostly coal and natural gas. So the electricity in your batteries isn't from a sustainable source. And so as soon as I finished my PhD, I tried to find a job in the renewable diesel space or biodiesel space, and I was lucky enough to get on board with my company. And so I've now been working in biodiesel and renewable fuels for 14 years. So now I know a lot about that. So I know a little bit about everything, but the only thing I really know a lot about is renewable fuels or biofuels now professionally. But the nice thing about that background in academics is that it teaches you how to analyze things, teaches you how to think about the big picture. I did some life cycle analysis, which is what people use now to estimate the impact on the environment of things. They talk about the life cycle impact of using a certain option for energy, and what does that do to the environment over the course of the lifetime of that product or that fuel. So there's all these little pieces kind of came together to make me sort of perfectly suited for doing what I do now, which is helping my company, but also talking to people. And I do a lot of public presentations. This is my first podcast, so I'm really excited to break into the brave new world of internet interactions.
So there's a commentator that I like to watch, and he has somewhat of a cynical view on the world, and that's not necessarily why I like him, but it's because it's kind of against my natural nature. His name's Peter Thiel, and he talks about how most of the fields that people went into imagining that they could be inventive, take aerospace to any field that you can think of, that eventually they become so regulated and so gummed up that you don't actually have people doing interesting, innovative, on the edge work. Is that true in the energy world right now?
That's an interesting way to put it. I think it's both call it corporatization, I guess, is maybe what he's pointing at, but there's also just the profit motive, right? Businesses only exist if they make money, and businesses tend to want to protect the way they are making money now. It's always easier and cheaper to continue to make money the way you have been than to change to something new. And I think that might be part of what he's touching on, so this idea of allowing the petroleum companies who have provided an invaluable service, right? They've allowed the economy of today to be what it is. So there's no doubt that they have served humanity, but to allow them to be in charge of the transition to more sustainable forms of energy is kind of backwards, because their natural tendency or their capitalist tendency will always be to continue to make money with their current setup, because that's a lot easier and cheaper than to spend billions or hundreds of billions of dollars transitioning to something else. So I think that his sort of cynicism certainly would apply when you get into that level of corporate behavior, partly because of that protective nature of capitalist endeavors. So startup companies, new companies typically have the ability to do new things without that resistance of having to continue to do the old thing. And so I feel like my experience so far as part of a company that's really only 15 years old is that in those early days, and we're still pretty much there, we are actually able to be entrepreneurial as long as there is a way to make money. And that's where things like, federal support, state support, policies come into play, because they allow new ideas to get off the ground. Solar is a great example of something that if it were purely left to the market would never have been installed. But there have been credits for solar for 15, 20 years that have encouraged people to install solar. Now that it got going, by the last report I read, solar is now, if you had to build a new power plant from the ground up, solar would be the cheapest kilowatt hour you could build. That would not have happened without government support, and it would not have happened if we'd left it in the hands of the utilities who are burning coal and natural gas.
Well, okay. I think you could say it would not have happened this fast, but you could be saying that there were several generations of solar energy that was produced that was, wasteful and not efficient, and would have been a market failure had it not been for the government support. But I wanted to actually go back, because you had a term in there that I think is an important one to define, which is the word sustainable. And I don't mean to be pedantic. Like, I'm not going to sit here and be like, what are the 3 R's of the blah, 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 all the garbage that people put into their sustainability reports. What I mean is, like, brass tacks. What does it mean to you to be sustainable, and how do you make sure that your definition isn't just drawn around your company?
Yeah, that's a really good point, because now that I'm involved in the capitalist endeavor, we have to keep making money. But to me, sustainability is something that really, as I kind of implied earlier, got me into this field in the first place. It got me to go back to graduate school to work on my PhD. And to me, sustainability means something that can be done indefinitely. By that, I mean, as we interact as humans with the environment, whatever we're doing allows us to continue, hopefully something similar to our current quality of life, right, or better, as indefinitely into the future. Anything that causes even small incremental damage that may accumulate to prevent us from living the way we live would not be sustainable. Things that either maintain or improve the environment and our interaction with the environment, and by that I mean the physical environment of the world, would be sustainable to me.
That seems fair. How do you apply that then with my concept is that human beings have an insatiable energy demand, right? And really what energy is the ability to do work, to allow somebody else to move, something that's heavy from one place to another, or accelerate really quickly, or whatever. All these forms are to make it so we as humans don't have to physically lift these things up or move them around or heat them or cool them, any of those things. But I don't imagine that the future is going to be one in which our demand for that energy will go down. In fact, I think it will go up by orders of magnitude.
Right. Well, yeah. So yes, certainly it goes up. I think that's been proven, but efficiencies also have been going up steadily, and people's ability to pay attention to waste. So when I was it was in 1993, I wrote just a little paper for a class about how much could be saved just by being more careful with not wasting energy. Same applies to water. If we're very careful about not wasting water energy, we could cut our consumption about 50%. Now that was back then. I think there's a lot less waste now, but there's still a substantial amount of waste. So reducing waste actually can prevent that incremental or exponential growth even. The other one is just more efficient technologies. And this is where, to be fair to electric vehicles, for example, electric motors are more efficient than combustion engines. So it's not to say that electric vehicles or electric transportation isn't going to happen and be an important part of it, but they actually can, under the right circumstances, get more work, as you say, out of the same amount of input energy. So between those efficiency gains, better control of waste, and even though the population is still growing, hopefully it's starting to flatten out a little bit. We're still probably heading towards 10 billion people or more, but the rate of growth is starting to slow down. So I actually feel like we can probably do as much as we do over time without a whole lot more energy input. That'd be my personal opinion. If we're careful, and if developing nations are also careful, and so that's one hopeful thing, I guess, right? Is that if we set the target not as 10 times what we need now, but maybe 2 times what we need now, how can we, and then that can decline over time. How can we achieve that in a sustainable way? And that involves, of course, minimizing things that are doing small but cumulative damage.
As I hear your enthusiasm or your passion for sustainability or your concern about carbon going into the air, I know this is something that you're not supposed to say out loud because there is such a push around climate change and the danger it presents. But it is not on my radar as something that I spend any time at all thinking about. And I think in large part that's because if you have a stoic mentality of, I am going to try and control the things that I can control, it appears to me that I have about as much control over climate change as I do over the presidential elections, which is I can have an opinion. I can feel informed enough to have an opinion, but not my opinion actually amounts to virtually zero.
And I guess I would say, but did you vote? Because voting is that act of hope, if you want to call it that, or optimism. If everyone votes, then it makes a difference. If everyone pays attention to this, it makes a difference. But the place where it really happens, this change you're talking about, where you're right, you or I individually can't do a whole lot, right? But what we can do is support policies, because at this point, governments, or in the case of large corporations, pressure from their customers, right, to do things can make a huge difference. Companies have the ability to be more energy efficient, to use more renewable energy sources. It just is expensive, has been at least. And so therefore they need that pressure to do it. They need to make money. The government can create policies that do cause our carbon intensity or our carbon output to go down at a scale that does matter, right? The US economy is whatever, a third of the world. So we can make a difference that way. So you're correct. Your individual actions are probably going to add up to a tiny bit, but I would still be optimistic and say if everyone did those things, it would make a big difference. But also from a policy standpoint or a consumer standpoint, encouraging the people who make a big difference to do things that help has a huge impact.
On this podcast, we talk a lot about the kind of animating spirit, the thing that causes you to be excited or go towards something, your daemon, that inner voice that says, hey, you should go work on this. Why does your daemon say sustainability is important?
So going back to when you first asked me, how I define sustainability, I just get I'm an engineer, so I get a little bit of obsessive about finding the details that could cause a problem in the future. And it seemed to me all along that our use of fossil energy, and by that I mean pulling carbon-based fuel sources out of the ground where they were sequestered, burning them and releasing them in the atmosphere, was something that was going to be a big deal. And I personally believe the data I've seen from all the climate scientists and everybody showing the accumulation and how it trends almost perfectly with global mean temperature, surface temperature rise, the impacts on the ocean, these tipping points where you start to lose your fish supplies, your coral dies, the pH, the acidity of the ocean changes. There's all these things that are really terrifying when you think about them. And so as an engineer, I felt like, well, those are big potential negative consequences. We better get in there and do what we can now. And that's kind of what got me into renewable energy in the first place, and got me back into chemical engineering after my hiatus. But I feel like that is the thing where if you feel like you have you're doing a podcast because you can reach people, you can generate these conversations that might impact how people think. I'm doing renewable energy and biofuels because I feel like that's a place I can make a difference. My background allows me to contribute. So I'd say that's the inner motivator, is having the opportunity to make a difference and trying my best to take advantage of it.
It's interesting. My motivating factor for doing the podcast is not as much for me to share what I know with other people, but that I can then get people like you to come on and answer any question that I have, right? And if you think about the 200 or so interviews I've done, I've gotten to have 200 hours of other people's time to be like, well, what motivates you on the deepest level? But right. I see that the end result ends up being that the knock-on effect of the work that you do, it does impact people, right? People say, hey, I listened to that thing and I changed my point of view. Mm-hmm. When you think about the state of the point of view of the people you're trying to, that are essentially going to provide you your raw materials, which are farmers, is my understanding, what do you think the state of their acceptance of global warming as dire as you think that it is?
That's a very interesting question for me, because I'm on the production technology side. I think so when we make, just to get into the technology that I work for, so we make biodiesel that's made from any oil or fat, and you convert it to a different molecule that's used in a diesel engine. So we need oils and fats, which, as you say, as farmers, we also can use waste oils and fats, so cooking oil from restaurants and things like that. So we have a wide pool of things, but they basically have to be lipids or oils and fats. So farmers really in the US don't grow anything for the oil or fat, canola being a bit of an exception. But soybean oil, for example, is the most common veg oil in the US. Farmers grow soybeans for the protein, for the meal to feed to animals. So we're getting their byproduct. People grow pigs, chickens, and cows for the meat, not for the fat. So we're getting their byproduct, right? They use cooking oil coming from the restaurants. So we're always using the byproducts. So I think farmers appreciate the added value by creating this market for biodiesel and making biodiesel. Just to use another example, 10 years ago or 15 years ago, use cooking oil, restaurants had to pay someone to come pick it up because it was a waste. It had no value to them. You couldn't put it down the drain. And so they had to pay someone to come pick it up. Now, because of biodiesel, they have to lock it up because people will steal it from behind the restaurant. There are all sorts of stories of people driving up with a truck and pumping out someone's waste oil tank because it's now worth real money because we can make a product out of it. So that's an example to say where we have this value that we put into the economy that does make it back to the farmer, but I don't know that they see us as directly as they see like corn prices, right? Because corn prices are their direct product. They see that. We're sort of behind the scenes. So I say that as a long way of kind of leading up to the idea that I think farmers generally are very supportive of the biodiesel industry where I work, but they don't quite tie it together. They're not as supportive of biodiesel as a product as they could be, because they use a lot of diesel, in their farm equipment, for example. So I've always thought that they're supportive, but they're not passionate advocates for our product, which is, I think, has to do with these levels of distance, which kind of gets back to your point about what's somebody's selfish interest. Well, if they can do something that'll add $1 a bushel, they'll do that. if we're only adding that dollar a bushel through a very convoluted economic system where it's a byproduct of a byproduct and it finally makes its way back to them, we're not quite as visible, which is one reason I like to do a lot of speaking opportunities, because people aren't really even aware that our product exists a lot of the time. Because the other thing in the US, we don't drive diesel engines very often as passenger vehicles. I mean, there are lots of pickup trucks out there. Europe, 40 to 50% of the passenger vehicles are diesel. In the US, it's a tiny single digit fraction.
That's shocking to an American. And I think from my perspective, I always think, man, diesel's so dirty. Like when I was around farm trucks and all of that stuff, like it smells and it burns. Why is Europe so heavily leaning towards diesel?
So they have been all along, and for years. I mean, since World War II, diesel engines are more efficient than gasoline engines. And that's just kind of one of these thermodynamic fundamental facts about the way the engines work. The most efficient engine you could make on a combustion side would be what's called a compression ignition engine. And that's what diesel engines are. There's no spark plug. It compresses the fuel until it ignites. So thermodynamically, that's the most efficient way to do it. And not just thermodynamically, it has to do with how the flame propagates through the cylinder as it burns. So just know that. And therefore, because just like European passenger vehicles are typically a lot smaller than those in the US because fuel economy. So for fuel economy reasons, they have been using diesels as passenger vehicles for decades. A diesel engine, can get 50 miles per gallon, whereas a spark ignition is lucky to get 35 miles per gallon. So, or 40 maybe now. So that's why they use them in Europe. The US has always had relatively cheap fuel prices, other than a few spikes here and there. So the fuel economy push hasn't been nearly as prominent. And so therefore we used gasoline because of that perception. It's cleaner, burns cleaner. It's easier to use. There's wintertime issues where diesel fuel can gel up, whereas gasoline flows year round. So for a variety of reasons, the US dominantly gasoline, Europe about 50-50. And because of that, most people like you or me, before I worked in this industry, I didn't know anything about diesel fuel. All I knew was, like you saw, the black soot coming out of the buses as I was riding my bike behind them when I was going up to my office and when I was in graduate school. So back to your point, then, I guess diesel definitely has a reputation of being dirty. And historically, there was a lot of visible soot, visible pollution coming out of diesel engines. The EPA created rules for diesel engines that started 15 years ago and have been ramping up, where diesel engines now, we call them Tier 4 or new technology diesel engines, have so many emissions controls on them that the exhaust coming out of them is cleaner in many cases than the air coming in the front. So the air that goes in to burn often has more stuff in it than what's coming out the tailpipe. So new diesel engines are actually extremely clean. They're as clean as gasoline engines, if not cleaner in some ways, because they have more stuff cleaning up the exhaust. But
I ride around with workmen all the time that hate the is it a catalytic conversion? Is that what it is?
Right. Yeah. So catalytic, there's what we think of as a catalytic converter in a gas car is basically just burning up the excess hydrocarbons. So you don't smell, the gasoline smell, and that doesn't get emitted in the atmosphere. There are 2, if not 3 different catalytic converters on a diesel engine. One that reduces NOx, nitrogen oxides, one that reduces the hydrocarbons, and then one that does kind of a cleanup of the stuff that comes out of the NOx conversion. So, and then they have what's called a diesel particulate filter, which is a big monolithic honeycomb thing that all the exhaust has to flow through and all the particles get trapped in the diesel particulate filter. So those newer, if you are still smelling or seeing anything coming out of an exhaust of a diesel, it's probably an older technology diesel engine.
So when your company produces a biodiesel, then who do they sell it to? Can anybody just pull up and start putting that in their tank?
That would be nice, because I have a diesel Jetta that I bought when I first started working here that I don't have a good place to fill it up. It depends on the state you're in, but for the most part, we would be considered a big company in the biodiesel space. So Renewable Energy Group is the big one in the US. We historically sold it to petroleum companies who had an obligation to acquire a certain amount of renewable energy credits, or called RINs, renewable identification numbers, which they can get from ethanol, they can get from biodiesel, they can get from other renewable fuels. So sold a lot to them. We would sell to truck stops the big major truck stop companies that you see along the highway, they would blend it. They would get those credits, and they could sell those credits then. Wait,
who are they selling the credits to? Is this yeah, yep. Let's talk about this.
Right. So this is a federal program. Once again, it was started by George W. Bush. It actually came out of a Republican administration. It's the Renewable Fuel Standard, the EPA's Renewable Fuel Standard program. And they created requirements for refiners and importers of petroleum. So if you either refine the petroleum in the US or you import petroleum into the US, you get an obligation that you have to meet it's called your renewable volume obligation. You have to acquire so many of these credits, these RINs, to satisfy that based on the size of your production or your importing. So basically proportional to how much petroleum you're bringing into the marketplace. And these volume obligations have ramped up fairly slowly, but they've ramped up over time. And that's the Renewable Fuel Standard, RFS. So RINs are these credits that get attached to the renewable fuel, whether it's ethanol or biodiesel or something called renewable diesel, which we also make now. But those credits have to end up in the hands or the pockets of the petroleum companies. So they can either buy the fuel from us directly and get the credit with the fuel, or if we sell it to someone else who blends the fuel with petroleum to go out into the world, like a truck stop, they then have those credits which they can sell back to the petroleum companies. And so there's a trading market for these RINs, for these credits.
What is the power differential between a gallon of diesel and a gallon of your biodiesel?
Yeah, that's a really good question. So the absolute, if you just took a gallon of each and burned them, right, you would get about 6% less energy out of the biodiesel, roughly. So when you blend, most biodiesel is used at blends of B20, so 20% or less. So at B20 or less, it's about 1% less, which is probably going to be tough to detect. Although biodiesel does have two mitigating factors. One is that it actually burns much more cleanly. So if you had those old engines we were talking about that put the black smoke out still, if those engines would use straight biodiesel, the black smoke goes away. So that's a lot less particulate matter, a lot less hydrocarbon smell. So you get more efficient combustion because biodiesel has oxygen in the molecule. It's an oxygenated fuel, so it burns better. And the other one is biodiesel is very lubricating. And I didn't know this till I worked in the industry, but diesel engines, the cylinders are partly lubricated by the fuel. So the fuel itself has to be lubricating, and petroleum diesel has a lubricity additive added to it so that you don't get more friction in the cylinder, cause energy loss, right, to generate heat. So the combination being more lubricating and better burning, in practice, many studies have shown that at that 20% level, there's no detectable fuel economy difference. And sometimes biodiesel blends even do better. Depends on the drive cycle, how you're driving, start, stop, for example, does better with biodiesel than with petroleum diesel. Long haul trucking or railroads kind of burn at a real steady rate. So you start to approach that theoretical number better. But so the short answer is a little less per gallon. The long answer is when blended, and in practice, it comes out to no detectable difference. And most people use 20% or less biodiesel.
I'm kind of chuckling to myself because if you've been kind of an environmentalist, chemical engineering hippie for 13 years, then you are actually enduring the first ag, thing that people really hated about ag. Before it was GMOs, a lot of people don't realize that it was a lot about we're making all this corn to sell it to gas companies that it actually doesn't produce as much as it costs to make it, right? That was the complaint that people made all the time.
Right.
How true was that, and is that still true? Is it require more energy to create biodiesel than you get out of it?
Yeah, so I'll make a quick distinction. There's ethanol, which is corn starch, right? You grow the corn, the starch gets converted to sugar, you make ethanol. That's the one that I think has been under the most scrutiny or criticism about maybe not being a net gain. So as I mentioned, for biodiesel, we use the waste oils. We do use corn oil. There's some corn oil you can recover from the back end of an ethanol process. It's pretty gross. You don't want to eat it as a human, but it could be fed to certain animals. But for the most part, you don't want to eat it. So we do use that. But the starch is the one that kind of gets the big scrutiny. So my personal belief is, ethanol is definitely lower carbon intensity across the value chain than petroleum gasoline. And biodiesel, because we're making ours from these byproducts or waste products, is easily more sustainable or lower carbon intensity than petroleum diesel. This is where we get into the policy and I'll take the hippie label. That's fine. That's fair enough. There are pictures floating around of me back in the day with long hair. So
I figured.
Yeah. But the part that kind of, which I feel is unfair as a Midwesterner, I suppose, but also just as a science person, is that a lot of the carbon intensity that is assigned to corn or soybeans is not based on the direct production. Because the direct production, you know your inputs. You're burning fuel, you're putting on fertilizer, you got labor, you're hauling the products around. Those are all easily quantifiable. And based on those, ethanol and biodiesel are way lower carbon than petroleum. But what a lot of environmentalists and environmental science folks have done is they've said, well, wait a minute, if you're growing more crops, somewhere in the world, somebody's chopping down the rainforest. And they've assigned something that's called indirect land use change. So not direct land use change, which would be measuring how much rainforest is being cut down, but indirect land use change, or ILUC, is this penalty, I guess, that gets assigned to biofuel or biocrop production based on the assumption that any incremental bushels came from somebody deforesting the rainforest eventually, right? Eventually, because you added more value.
So there's no way out of it. Like no matter what, if you're gonna count this fuel, you're gonna get like, well, then we had to burn down some rainforest for it.
That's kind of how they're. So that's where you get into this interesting situation where it depends on the jurisdiction, right? So Europe is very concerned about rainforest deforestation. So they've assigned these very steep ILUC, indirect land use change, or imaginary land use change, as I like to call it, but these steep ILUC penalties.
I love the hippies getting mad.
Yeah, I'll get there. You'll get me there. But so they've got very steep penalties. So therefore, crop-based fuels over in Europe are not seen as sustainable. Whereas in the U.S., it's a little more modest. California is kind of somewhere else, because anybody who writes their own rules gets to assign the ILUC value. Canada, interestingly, has been in the provinces has been pretty minimal on their ILUC penalties, and partly because they're growing canola up there mostly. There's nobody growing canola in the rainforest, right? Canola is a cool weather crop. So they've allowed it, but they've also taken a much more fair approach, in my opinion, to soybeans, because soybeans, sure, you can grow them in the rainforest, but the National Biodiesel Board, which is our trade organizations, and plenty of academics have shown that we've gotten all these extra bushels on the same amount of land just by better genetics, seed genetics, and better farming techniques. So there's a lot of proof that this land use change stuff is imaginary, but once an idea gets root, it's really hard to uproot it, and especially, at the policymaker level. So a lot of what you will hear are people saying, oh yeah, ethanol is worse than gasoline, or biodiesel is not as good as they say it is. But that is actually almost entirely because of this ILUC assignment. Whoever does the modeling picks their number, and the majority of the carbon intensity that's assigned to us is biofuels being us is from this land use change.
Well, man, I would love to see what the ILUC charges are when you put up a wind farm and you are literally displacing, hundreds of acres of actual cropland, right? Because
they don't get those. Yeah.
That's weird, because you're literally getting rid of the farmland. It's not like, hey, this year we decided to grow beans and those beans are going to go over there. You've made a permanent or at least 30-year commitment on that land.
That's right. I never thought of that, but that's a good point. So they'll have to assign some kind of land change penalty to wind and big solar installations someday. But
I mean, that actually kind of reveals my hidden, I don't know enough about energy to have a strong, I have strong opinions loosely held, but my sense is we're looking at a lot of technologies like wind and solar that are nowhere near as bountiful as nuclear. And that the thing that we're offsetting because we're afraid of nuclear power is that we're literally taking the most valuable asset that we have in the United States, which is farmland, and we're putting giant metal robots on it that are only getting, a fraction of the energy that you could get out of nuclear. How does that sit with the chemical engineer in you?
Yeah, As part of engineering, you always get into safety, right? Part of our and nuclear is scary in that regard, right? There are a lot of issues around the waste that's generated, the fuel that goes in, the potential for an accident. So I personally think nuclear is a valuable part of the energy spectrum. It's low carbon. There's no doubt about it, but it is limited in the sense that locations for plants and how you deal with the waste, in particular the waste, is kind of limited. So I wouldn't want to wholesale switch to a whole lot more nuclear, but I do think that the nuclear we have already built, we've already paid for, already has all this stuff in place, should be continued. So I'm a fan of keeping the nuclear we have. I'd have to think more about it to give you an opinion on adding a lot more. But I also think that wind and solar, wind is a little dicey, right? I mean, we're in Iowa and we get a lot. I think we're up to like 40% of our electricity in Iowa is now from wind, because we're a good state for wind. A lot of wind, a lot of exposed places for turbines. So I think wind can really work well in the right places. So I'm a fan of wind in that regard. But once again, you don't want to just start sticking turbines everywhere, because your point about displacing farmland is good. Also, they need to be efficient to justify their location. Solar is another one, though. Solar is one of these that's kind of become more and more efficient over the years. I mean, the amount of electricity you can get from a panel, a square foot, has gone up by 10 times.
Oh, it shocked me. I was getting some survival stuff with like little panels that you just set outside.
Yeah.
And I was stunned on a direct but winter day where you don't have that much sunlight. You can power. You could at least charge a laptop with one of those things that you set outside. So that is pulling down some serious wattage.
So I think solar is one of those examples. As I mentioned, I think just this year they crossed over. If you had to build a new power facility from the ground up, solar would be the cheapest per kilowatt. Now that depends on where you are, versus the equator and everything. You couldn't do that in Alaska, but in the U.S., especially the lower 2/3. So I guess what I'm getting at is I actually do believe solar and wind should be exploited as much as reasonable. Your point is good. You don't want to take too much productive cropland out of business, but if the farmer gets paid a reasonable fee for the land and still farming efficiencies get us more crops per acre, I think we can kind of manage that one. Solar is a great option. The problem with nuclear is good because it runs all the time. And by that, I mean your nuclear reactor can run 24/7. The problem with solar and wind is not that they're not great sources. It's just that they are good for what I'd call the base load. And solar, of course, doesn't shine overnight. So you need something else to make up what I would call peak demand, meaning those transient demands. Everyone comes home from work, turns on their air conditioner all at once. All of a sudden the demand goes way up. You can't turn up the sun, you can't turn up the wind. So what we really need is as much base load from our renewable sources, and then figuring out what's the smartest way to add that incremental load, either when the renewable sources are lower output than expected, or we just have a peak demand. So nuclear's turns up pretty well. Historically, the best way to turn up the current is coal or natural gas, because you just crank up that power generating station. So most of the peak power generating stations that are being built in the last 5 years have been natural gas. It's cleaner burning than coal. We have a lot of it. It's cheap. So getting that peak demand is the big question for me. And biofuels can be burned to make electricity too. So there is someday a potential opportunity for renewable fuel to be used to run turbines and make electricity. Right now, it's just more expensive than natural gas. Natural gas is so cheap in the U.S. that it's hard to get anybody to consider anything else.
In the beginning of the podcast, we were talking about how demand will increase. And when I think about demand, I think of a place like Kenya, where at least when I was living there about 15 years ago, most houses did not have electricity. If you were outside of the city, you didn't have electricity running to your house. And you're still using charcoal stoves inside of your home to cook your food or to heat your water, to heat your bath water, right? They don't have any of these as possibilities like that they can just turn on an appliance. So as you think about bringing up and matching the demand that is all over the earth, how do you think that plays out over the next 10 to 15 years?
Yeah, that's another great question. I think one of the nice things about a lot of the third world is they do have typically a lot of sunlight. They're not living in Antarctica or northern Canada. It's equatorial type stuff. So I think we mentioned solar as a great way to bring electricity, at least at device scale, phone, laptop, lights, to those areas. But the other one is how do you handle applications where electricity isn't necessarily the best answer? And so I feel like, this is my bias, but this is why I work for the company I do, is, biofuels actually offer that fill in the gap option for liquid fuels. Because one of the things I was thinking about the other day when I was talking to people at my company is, when you look back at developments over the centuries, you could make an argument that liquid fuels changed the world as much as anything. It's easy to say, oh, electricity changed the world or this, but liquid fuels contain an amazing amount of energy in a very small, portable, transportable package.
And it only takes you realizing that people used to build ships and go out into the coldest North Atlantic water, get on little tiny rowboats, and harpoon the largest mammal, on
right.
Earth, drag them on board in order to rip them open and have that sweet, sweet whale oil to turn into lamp
to run their
light,
lamp.
right?
Yeah,
exactly. And
yeah.
so you think about that, then you start realizing like, oh wait, once we got gasoline, that's a total game changer.
And I feel like that's what, as a society, we overlook. The most common people have no sense of how energy dense and amazing and revolutionary liquid fuels are, because they allow that truck to drive across the country or the railroad to drive across the country without having to stop every 50 miles and put more wood or coal or water on. You couldn't have air travel. There would be no aircraft without liquid fuels. Ever. There would never
it'd be hard to keep them up in a char.
I mean, you'd have the
charcoal.
dirigibles, right? You'd have the Zeppelin or whatever. So when you think about that's just sort of that sense of wonder. Wow, what did liquid fuels do? But it also means they do things that are almost impossible to replace. So electricity can replace a passenger vehicle pretty easily, because think about the way we drive. I need to drive back and forth to work, to the store, and then I can put it in my garage and charge it overnight. I don't have to run it 24/7, and I don't really use that much. It's not energy dense. I'm not having to haul 40,000 pounds of something 400 miles.
Yeah, the roads have like no further of a grade than 30% or whatever on the steepest hill you can get to.
Right. So I think finding renewable electricity, which solar is a great example for the third world, but also having more sustainable or cleaner for the environment liquid fuels is part of the key. And then thinking about what is a good choice to replace with electricity and what is a bad choice to replace with electricity. A good example is, a heavy duty engine needs all that power. If you had a battery electric, you would, you spend roughly 2 to 3 times as much time charging it as running it. So you'd have to have multiple vehicles, or you'd have to have multiple battery sets. And these batteries are big and heavy, much heavier. It's about 15 times heavier per unit energy than liquid fuels. So it doesn't make sense to do electricity everything. And I think a lot of our policymakers get hung up on, I need a one size fits all solution, and they think it's electricity. So I think electricity will cover a lot of those things, should cover a lot of things that are good for electricity, that make sense. But heavy duty work, long haul trucking, rail, ships, aircraft, that's going to have to be, if we're going to go to a lower or eventually zero petroleum world, that's going to have to be liquid renewable fuels. And those work well in the third world as well, because you can transport them easily. You can store them safely. But, biodiesel, one of the things I love about it, it's essentially like vegetable oil from a safety standpoint. It's not flammable. It doesn't have any odor to speak of. You can store it in your wherever, and it's not a hazard. If you have to clean it up, you can clean it up yourself. You don't have to call in, the hazmat suit folks. So I think it's a great option for the third world. And that electricity hopefully can be more and more distributed. You can have these solar stations that don't need to be connected to a nationwide grid anymore. And, that's one of the beauties of distributed electricity generation.
So as you're spending time thinking about the future of energy, not just with the biofuels that you're in, but all energy futures, what do you think is the unexpected thing that seems obvious to you, but people that aren't in this space have no idea is going to come about with regards to energy, how they use it, how it's available?
Man, well, so I don't want to repeat what I said, but the one thing that people I don't think appreciate is how much energy is in liquid fuels when they start to talk about removing them. But I think the other thing may be that, call it hybrid approach, like there's hybrid electric vehicles now that can kind of maintain the advantages of some liquid fuels, right? But also have the battery that can get that extra energy when you're braking or whatever. I think there are a lot more applications like that will come about, right? Where we have a base of renewable electricity and then finding unique engineering ways to utilize those unexpected peak demands in power generation of liquid fuels, or even in like heating your home. There's been a big push in the Northeast. I know we're both Midwesterners, but the Northeast uses 4 billion gallons a year of diesel fuel, heating oil, to heat people's homes. They just don't have the natural gas distribution infrastructure we have. So there's been a big push in policymakers, and of course funded by the electric utilities, to replace all those heating oil systems with electric heat pumps. Electric heat pump is like a air conditioner that's running in reverse. So it's bringing in heat from the outside to the house.
Yeah, a geothermal system. I have one.
Well, geothermal, you're bringing in heat from the ground. That makes perfect sense. So good for you. These electric heat pumps are air-driven heat pumps, so they bring in whatever amount of heat they can gather from the air. I won't get into the how it works from an engineering standpoint, but those work really well in like North Carolina, where a cold day is 40 degrees. If you're in Maine and a cold day is 15 degrees, they don't work at all. So you actually have to have supplemental heat. Electric resistance heating is a terrible idea, like your stove, your range. So oftentimes you have to have fuel anyway, but you can have a thermal heat pump. Now this is in the future. We're talking, these are 10 years out, but a thermal heat pump where you have a very small burner that burns some fuel, and I'd say it should be a renewable fuel, burns some fuel, could be natural gas. It does that. It causes the air conditioner, that's the supply of heat, to make the air conditioner run in reverse. And because that air conditioner is run by compression and evaporation of the refrigerant, it's actually a whole lot more efficient than trying to just burn the fuel for heat. So you get that engineering advantage of using the refrigerant, compression and evaporation, which multiplies your energy output massively. And you just provide a very small amount of heat by burning a liquid fuel or a natural gas fuel. So there's those kind of, I'll call that another hybrid, right? That's another hybrid option, where if people are flexible and they try to just take the advantages of a given system without shoehorning it in to a situation where all the disadvantages are really important, like the idea of long haul trucks being battery electric, where a third of your cargo space is batteries. How does that, I just don't understand why anyone thinks that's a good idea, but people do.
I think when people think about the future with energy, most of it is like a Disney kind of thought about it, in terms of they've not really thought about the details, but they imagine within the next 20 years or 30 years, or probably they would think 5 or 10, that there'll be some giant leap forward, some innovation. So you've made a lot of predictions today about like liquid fuel and how all this will work. When do you think, how long are your predictions good for? Would you say these predictions are good for 100 years? Are they good for 50, 20?
No, definitely not. I'm not that good. And I could be wrong with all this anyway. So, maybe they're not good at all. But I feel really comfortable for the 10-year window, saying it's nice to think these things are going to happen, but really everything takes time. As an engineer, that's one thing you realize right out of the gate when you leave school is, wow, it takes a long time to get any of this stuff to happen. It takes 5 to 10 years for, our company's been around for 15 years and we're finally getting some real traction. Ethanol spent, 30 years before anybody really started paying attention to it. So I think for 10 years, we're definitely in a situation where we need to not rely on the magic. I like your Disney example. The magic of all of a sudden electricity will be available everywhere for us and it will all be sustainable and renewable, because it's going to take decades to get the electric grid to where it's majority, overwhelming majority renewable, because hydroelectric is used where it can, but that's only where it can. Nuclear power plants are built. You mentioned nuclear. Building more nuclear makes me a little nervous, but I also know it'll take 20 years to build a new nuclear plant because of all the permitting and safety things. So even if we decided now to build more nuclear, we wouldn't have it for 15 to 20 years. So for the next 10 years, I think we're going to be in this interesting situation where people think everything's going electric. Hopefully they get educated to realize that, hey, that electricity isn't always as green as you think it is, because you're in a state that still uses a lot of coal-fired power plants, or you're using natural gas-fired power plants, which are still fossil fuels. So I think we're looking at about 40 years probably to get the grid really kind of converted with more solar, wind, maybe some more nuclear, maybe some more hydro, a lot more efficiency, a lot more insulation in your house, whatever. Pick your way of making things more efficient. And along the way, then we're going to need liquid fuels, in particular diesel fuel, because of those high energy demand applications, or jet fuel. It's another one where you can't replace it with electricity. So I think by that point, I can't say what will happen, because there's very likely to be some breakthrough in battery technology, or something that I just can't imagine. People getting plants that directly photosynthesize electricity or something. I don't know. There'll be the algae pond that's pumping out electric current.
The algae pond, that's a great one. That's one that I think there was a lot of hype. I remember 5 years ago, people being like, and I was definitely on that camp. Like, imagine you could put little clear tubes of algae in Africa and extract all that solar energy and turn it into some kind of biodiesel. But it does seem like that is a lot further off than where it was when I first heard of synthetic biology.
Yeah, my joke for a while has been, algae's been 5 years out the whole time I've been in the 15 years I've been in the industry. So it's all, but I will say one thing, your point about the pond in Africa, that's where these breakthroughs in solar technology, I think really, they have made that the most efficient way to use the sun. But there are still lots of opportunities to grow algae for the biomass or the oil to make biodiesel out of, or whatever. We have, my company's used a little bit of algae oil. The thing that we ran into is that because these algae can be kind of cultivated, you can make high value fats and oils like omega-3 fatty acids, that are really popular for dietary supplements. You can breed your algae to make omega-3s, and they get paid a whole lot more for that oil than we can pay. We're buying stuff that's 30 cents a pound, and the soybean oil is 45 cents a pound, and then there's the omega-3s that are $2 a pound. So
you just made an entire section of my life make sense. I never understood Monsanto when I was working there was always in pursuit of this thing called Vistage Gold or Vistive Gold. Yeah. And I knew a lot of people working on that project, and nobody could ever help me make sense of why are we after this pursuit of omega-3s? Because I don't care about that oil, but I didn't realize how much more valuable it was than the rest of the fats.
Right. If you can kind of concentrate it up or purify it, you can sell those omega-3 concentrates for a lot more money than what we call regular veg oil. Yeah, and I remember Vistive and the high oleic acid soybean oil, which I still think someday that will find a big application, because that particular fatty acid, the oleic acid, is a really good one for making fuel and other things, lubricants and things out of. So all that work will probably come around. That's the other thing I've seen now, is that eventually those good ideas do find a way to be used, but it's often not on the time scale that people think. So back to your point about,
you want to tell the poor bastard grad student, hang on, buddy, it's going to be a little while.
If it's a good idea, eventually it'll get used. But that's back to your point about the predictions. I think we're kind of in that period where people thought that the electrification of everything was going to happen and save the world. And now that it's getting closer, and it's been a few years, people are realizing, wait a minute, first of all, it's not going to happen as fast as we thought. And second of all, the world actually has to support the electrification. We still have a ton of coal-fired power plants. We still have a ton of natural gas-fired electricity generation. So that's what you're using. Now, electric motors are more efficient, which is nice. And so you can get a benefit. But once again, now you got to have a battery. Now you have to have a grid. You have to have all these things, where with liquid fuel, all you need is a tank. And if the grid goes down, power goes out, I still got my tank of fuel, right? I can heat my house. I can drive my vehicle. I'm bulletproof. So there's a certain amount of value that people ignore when they want to tie everything to the grid of being self-sufficient.
So last two questions. First one, pretty simple. but pretty much yes or no. Would you recommend future generations to go into chemical engineering? Is there enough innovation to support a great mind going into that field?
Yeah, that's an excellent question, because I went in as an idealistic young person in the 80s, right, the mid 80s, having kind of seen the Carter years and the oil embargo, and then Reagan coming in and being a little less interested in sustainability and fuel economy, and I thought, well, there's a lot of stuff chemical engineers do, and I want to be one of the green ones. But I was 20 years too early. Like, those opportunities did not actually exist when I graduated. They do now. And I think what I've learned is, as I said, I went back to school to get my PhD. Chemical engineers are now involved in biotech, solar, doing materials development, nuclear, obviously, fuel combustion, chemicals, biomechanics, and making parts for prosthetic stuff and implants and things you put in the body. So anything involving molecules and engineering is chemical engineering. So the field has blown up in terms of the opportunities that are available. And I definitely would recommend, if someone wants to have a lot of options, chemical engineering is now a really intriguing major. Whereas when I did it, I didn't realize it was pretty much everybody went into the petrochemical world, and that's what you did. And that's what your opportunities were. So the world has come around. So yes, I think it's a great major. It's challenging. It's a hard major because you're learning all the engineering and you have to learn all the chemistry. And so it takes kind of a unique person. But yeah, if you think you can do it, it's a great place to learn how to do a lot of things.
And I'm going to ask you for your favorite book about energy for lay people. And while you think about that, I'm going to give my book recommendation. So I read a book called The Bottomless Well: Why We Will Never Run Out of Energy. And I read it, it must have been 15 years ago. And the reason that I liked it so much is, as a layperson, I did not understand how the orders of magnitude of energy worked. Like, how much more energy do you get out of a gallon of gas versus an hour of wind blowing or nuclear energy? And so for me, that fundamental understanding opened my eyes right before I went to Kenya, of like, oh, now I'm watching people that have no access to these bundles of energy. And I think even if I hadn't gone to Africa, that was a very good book for me. So what about you? What's your recommendation?
Well, I'm a little ashamed to say I haven't read a lot of books on energy. I've just been working mostly. But there's a really interesting book called The Prize that my boss actually gave to me long ago. It's still, I've only scanned through it, but it's very intriguing. But it's about oil, money, power, the politics of global politics, and how all these different policy things have happened over the decades. And it's really eye-opening, I think, into the behind-the-scenes stuff that led to our current energy economy. So The Prize, I think, would be a really interesting read for someone who's interested in the policy side, how countries interact, how corporations interact with their governments.
Well, Dave Slade from Renewable Energy Group, what if people wanted to learn more about your company or can connect with you, how would they do that? Yeah,
so our company website is www.regi.com. We have a lot of interesting things there. I can be reached. My time's a little bit limited, but if someone wants to reach me directly, they definitely could reach out through our communications folks. So it'd be Katie Stanley. So www, or not www.
I'll just leave it in the show notes. You can send.
Yeah, you can leave it in the notes. I'd be happy to answer more questions, or if somebody wants someone to come talk to a large enough group, I'd definitely do it. Nowadays with Zoom, we can interact a lot more readily than we can when I used to have to get on an airplane and fly someplace. So yeah, we'd love to help people understand how all these things work together, and kind of our big thing, I'll leave you with this, Vance, is what's available today. What is available now versus what can you maybe do in 10 years? Because back to your point about how long my predictions are good, what I can say is right now we are not utilizing our biofuels to their full extent. We are utilizing all the electric vehicles we make. We're utilizing everything else, but we can make more biofuels. You're a Midwesterner. There's farmers with materials, products ready to go to market. And right now we're limited by demand, not by supply. So if people want to consider that as what can I do today versus what might I do in 10 years, that's the main message we like to get out to folks. And appreciate the chance to talk with you today.
Well, great to talk with you, Dave. And when I have some chemical questions, I'll have you back on the podcast.
Don't hesitate. Yeah, I'd love to talk again.